Hi everyone, this is a video that's going to go through some example problems using specific heat capacity. Remember, specific heat capacity is referring to the amount of energy needed to raise 1 gram of a substance by 1 degree. So the formula we are going to use is Q equals mc delta T, or Q equals mcat is one way I like to remember it, where Q is energy in either joules or calories, M is for mass in the unit of grams, C is specific heat capacity, which is a value that is either going to be given to you or you have to solve for it. And remember, this changes for different substances. The unit for that is joules per gram degree Celsius. And delta T, remember delta is change in temperature. And if we're trying to find the change in temperature, we're going to take the final temperature minus the initial. So let's look at our first example. Calculate the energy required to increase the temperature of 25 grams of water from 25 degrees Celsius to 80 degrees Celsius. The specific heat capacity of water is 4.184 joules per grams degrees Celsius. So the very first thing we're going to do is write our formula. So Q is equal to mc delta T. Okay, that tells me what variables I need. So then I'm going to list my variables. Q, mc delta T. Remember, Q is energy, and the question says calculate the energy, so that is what I'm solving for. M is mass, so 25 grams. C is specific heat capacity, and it gives that to me in the problem for water, so 4.184 joules per gram degree Celsius. And then delta T is the change in temperature, so remember it's T final minus T initial, which in this case is 80 degrees minus 25 degrees Celsius. And that answer is 55 degrees Celsius. So that is going to be my delta T. Okay, so now I can just plug these numbers into my formula. I don't have to rearrange anything because Q is already by itself, and that's what I'm solving for. Okay, so Q is equal to 25 grams times 4.184 joules per gram degrees Celsius, which is my C value. And then my delta T is 55 degrees Celsius. Okay, so now I can just plug these numbers into my calculator. So 25 times 4.184 times 55 equals 5,753. And Q is going to be in the unit of joules, and I got that from my specific heat units. Now, if we're trying to look at sig figs, remember when we're multiplying numbers, our answer has to have the least amount of sig figs. So in this case, it's 2. So I'm going to round this to 5,800 joules. Okay, just a reminder, when you're doing online homework, you don't have to use sig figs. Actually, don't use sig figs because if you do, it probably won't mark your answer correct. Okay, here's my next example. 4,000 joules of energy is added to 70 grams of copper, initially at 35 degrees Celsius. What is the final temperature of this sample? The specific heat of copper is 0.386 joules per gram degrees Celsius. So we're still going to use our Q equals mc delta T formula. Q, remember, is our energy, and it says 4,000 joules of energy. M is mass, so we're going to use 70.0 grams. C, remember, is specific heat. In this particular problem, we're looking at copper, and it gives you the specific heat, which is 0.386 joules per gram degree Celsius. And then our delta T, remember, that is our final temperature minus initial temperature. And this question is asking for the final temperature, and it gives us the initial as 35 degrees Celsius. So I'm just going to leave this as TF minus 35 degrees Celsius. Now our goal is to solve for TF. Okay, so let's plug these numbers in. Let me write out the formula first. We are going to have to rearrange this a little bit so that we can get temperature by itself. What we're going to do first is solve for delta T, and then we'll worry about the T final at the end. Okay, so to get delta T by itself, what we're going to do is divide mass and specific heat. Okay, so they cancel out on the right side. So now I'm left with Q over MC is equal to delta T. Okay, I'm going to flip these just so that I have delta T on the left side, and then I'm going to plug some numbers in. So Q is 4,000 joules divided by M, which is 70 grams, times specific heat, which is 0.386 joules per gram degrees Celsius. Okay, so now I'm just going to plug these numbers into my calculator. So 4,000 divided by 70 times 0.386. Notice that I'm using parentheses. So your delta T is equal to 148.04. I'm just going to round that for now, and this will be in degrees Celsius. Okay, so what this means is that your change in temperature is 148.04 degrees Celsius. Remember, we want to figure out what our final temperature is. So for this delta T, what I'm actually going to do is I'm going to take this and plug it in and write that instead of delta T. Okay, so what that looks like is T final minus 35 degrees Celsius is equal to 148.04 degrees Celsius. Okay, I'm going to add 35 on this side plus 35 on this side. Okay, that cancels out. And so I'm left with my final temperature. So 148 plus 35, that gives me 183. And if I'm using sig figs, we'll have 3 in our answer, so degrees Celsius. Okay, so our final temperature here is 183 degrees Celsius. Here is our third example. How much heat is released when 125 grams of iron cools from 90 degrees Celsius to 25 degrees Celsius? The specific heat of iron is 0.451 joules per gram degrees Celsius. So again, we're still going to be using Q equals MC delta T. Okay. The word that I want you to notice that is different here, it says released. How much heat is released? Okay, so what that means is my Q value now is actually going to be negative because that tells me it's an exothermic reaction and heat is being released. So let's just fill this out and you'll see how that works out because our temperature is actually going to become a negative because we're cooling now. So Q is heat, that's what we're solving for. M is mass, 125 grams. C, we're looking at iron, 0.451 joules per gram degrees Celsius. Delta T, remember, is T final minus T initial, which is, now in this case it says cools from 90 to 25. So 25 degrees Celsius is actually going to be our final, and 90 degrees Celsius is going to be our initial. So when I subtract this, we're actually going to get a negative number, and that gives me negative 65 degrees Celsius for my delta T. Okay, so now let's plug these numbers into my formula. So Q equals MC delta T. I don't have to rearrange this because I'm solving for Q. Okay, so M is 125 grams. C is 0.451 joules per gram degree Celsius, and delta T is negative 65 degrees Celsius. Okay, so now I'm going to plug this into my calculator. 125 times 0.451 times negative 65. So that gives me negative 3,664. We are looking at 2 sig figs because my temperature has 2 sig figs here. And remember, this is joules. So I'm going to round that to negative 3,700 joules. So that is going to be how much energy is released.